Hello, here is the solution for problem 24.37, which basically we have the loop and located, half of it located inside the magnetic field, and they ask you to find the magnetic force from that. Okay, so we listed this one in the PowerPoint previously, but the first starting point, so we have the currents goes through that loop, we select that directions. Now that those two current, they're not gonna be involved or contribute for anything since they are located outside the magnetic field. So I have this current and I have this current. Right hand rules, or in that case, which basically the V with the direction of the current, the magnetic field point to the page, and we end up with the force point up from this particular one. Let's call this one the top. And this one, you call this one is the bottom, or just POT. Okay, so on the first one here, we get the magnetic force will be indicated to the upside with certain angle. And similarly, we're gonna use the bottom one, we'll find the magnetic field or the magnetic force, sorry, going to this direction here. Basically, if you wanna imagine what we have that case here. We have, here is the force of the top. Sorry, here is the force of the top. And here's the force, or the magnetic force for the bottom. And the angle here is 45. The angle 45 for both, here's the 45 degree. Now, regarding for the formula, how to find the fire in the wire, or the force, magnetic force in the wire, which the formula, it is current times length times magnetic field multiplied by sine alpha. So the first one, we're gonna find the alpha, what that alpha is. It's not 45, by the way. It's the alpha, it is the force between the current and magnetic force, and magnetic forces. And which in that case, it is 90 degrees. So it's the alpha equal 90 degrees. So basically, fire in the wire, in that case, will be current, which in this case, 1.3 amps times length 0.05 meters times magnetic field 0.85 Tesla type sine 90 degrees. And if you calculate this number here, we end up with the 0.0525. Again, this is the force. I have one force here and the second force here. That's the force amount that we are looking for, or what we found right now, this amount here. And since this has an angle here, so I have to, since they are vector, to find the total magnetic field or the force, magnetic force, I have to, this is vector two component, one in the x component, for this one is x component, and the y component for the top. Similarly for the lower one, so it has the y component and x component. So here is the F bottom x component, and here is the F bottom y component. And the top one will be, here is the F top x, and here is the F top y. So now here is the bit adding a force for x directions, which I have two components here in that case. I have x to the top and fx the bottom. Here is the f x bottom plus f x top. So what do we have? We have this quantity for both. They are equal. So this one will be 0.05525 Newton times, what do we have? Here's the component, here is the F top cosine 45 degree, 45 degree plus cosine 45 degree 2 in the second part. And this is a quantity will be 0.078. Will be 0.078 Newton. Similarly, for the y component, summation of the Fy will be Fy in the top plus Fy in the bottom, which in this case, similarly 0.05525 Newton. And this one will be time sine 45 degree minus sine 45 degree. So the two components, they are in opposite directions. So this component will be equal 0 in this case. So this one will be 0. So now to find the magnetic field force or magnetic force, F, it will be 0.078 Newton. What is the directions in that case? So the directions will be in this side. This is the F net. And it will be to the right. That's the solution for this problem. Okay, thank you.